All right, Math 1, Unit 8.1 notes, continuing on with exponential growth and decay functions. So as I said before on the other video, we want you to be able to recognize an exponential function three different ways. First, by seeing the equation of an exponential equation, we'd like you to be able to recognize whether it's a growth or decay function. If we see a graph of a exponential growth or decay, we'd like you to recognize which one it is. And of course, if given a table, we'd like you to be able to recognize exponential growth or decay. Okay, so a exponential function is of the form y equals a, which is the initial value, times b, which is either your growth or decay factor, times or to the x, which is the exponent, which is usually how many times we're going to end up multiplying this. We'll talk more about that later. So A is the initial value, your starting value. B is the growth or decay of the equation, and X is the exponent. All right, so let's talk about B for a second. B is considered a growth factor if it is greater than 1. Okay? And B is considered a decay factor if it is between 0 and 1. So down here is a little better way of explaining it. So if our B is greater than 1, we know that this function is a growth function and B is a growth factor. If B is between 0 and 1, meaning greater than 0 but less than 1, then it is a decay factor, and this function will decrease over time. All right, so let's jump right in. Determine whether each equation represents an exponential growth or exponential decay. What percent increase or decrease does this function model? All right, we'll be talking more about this over the next couple of days. But when we talk about an exponential function, it is always increasing or decreasing over time. And so we want to be able to recognize what that percent increase or decrease is. So we have y equals 70, which is our initial value, what we start with. And our b is 0.50, which is between 0 and 1. So we know this is a decay factor. Okay, this function will decrease over time. Okay, now how much will it decrease? Well, it'll decrease by half. If we start with 100% and then we subtract 50%, we end up with 50%. But of course, we can't use percentages in equations, so 50% equals 0.5. Okay, moving on to our next equation. This is our initial value, what we start with. And our b is 1.35. That is greater than 1. So we know this is a growth factor. This function will increase over time. And, well, since it's growth, we must be increasing our percentage. So remember, we look at 12, and we always start with 100% of our initial value. In this case, we're going to add 34%. So our function is going to increase by 34% over time, which will give us 134%, and which of course equals 1.34 as a decimal, and that's what we have. So our percent increase is 34%. We started with 100% at 12, and at the end of one cycle, we're going to end up with 134% at 12. All right. So number 3, we have our initial value, and we have our b value, which is definitely between 0 and 1. So this is a decay factor, meaning our equation or function will decrease over time. Okay, now remember, we always start with 100%, and in this case, we're going to minus 55% to end up with 45%, which means, obviously, 0.45. So over time, we are actually decreasing by 55%. We have to look at this as what we started with, and this is what we will end with, because we lost 55% of its value. Okay, moving on. We have y equals, our initial value is 25, and our growth or decay factor is 1.019. which means that's greater than 1, only a little bit, but it is greater than 1, so this is a growth factor. Okay, it's going to increase over time. How much is it going to increase over time? Well, remember, we always start with 100%, And if we add 1.9%, we end up with 101.9%. Okay, and remember, as a decimal, that would be 1.019. So again, we started with 100% and we increased by 1.9% to get to 109%. Okay, and again, we will get a lot of practice with that over the next couple of days. So this is recognizing decay because it's between 0 and 1, growth because it's greater than 1, decay because it's between 0 and 1, and growth because it's greater than 1. All right, my graphs I should have picked better, but they're pretty, hopefully easy to tell. As X increases, Y is increasing over time. And on this one, so this is obviously growth. And this one, as X increases, Y is decreasing over time. So this is decay. Hopefully you're getting pretty good at recognizing those. And finally, how do we recognize exponential growth or decay over a table? Well, it's still pretty easy. We check and make sure our X is increasing by some consistent number, usually 1, 2, 3, 4. So increasing by 1. How is our Y values increasing? 3 times 4 is 12. 12 times 4 is 48. And 48 times 4 is 192. So as our X increases by some constant value, in this case usually plus 1, our Y's have to increase by some multiple to be a growth factor. Okay, a multiple greater than 1, obviously. And to be a exponential decay, again, our X's have to increase by some constant number, in this case 1, usually the case. And our Y values have to increase or decrease by some multiple. Well, 81 times 1/9 equals 9. 9 times 1/9 equals 1, and 1 times 1/9 equals 1/9. And so what multiple are we increasing by? 1/9, which is between 0 and 1, so this is decay. All right, I hope that helped. We will get lots of practice in the days ahead.